Welcome back to some more geometry. Today, we're talking about proving right triangles congruence. So up to this point, we talked about side, angle, and angle, side. Now, all four of these can be used on any type of triangle, whether it's obtuse, whether it's acute, whether it's a right triangle. Today's congruencies that we're going to talk about are four, and they're strictly for right triangles only. Now, it doesn't mean these don't work on right triangles, as there's a certain subset group that are strictly for right triangles only. Let's first dissect the parts of a right triangle. So on a right triangle, you have your right angle. They tend to put a little box in the corner where the angle is at. From there, you have your two legs and your hypotenuse. We also have acute angles as well. Sometimes they're saying, some they're not. But what matters the most is the hypotenuse and where the legs are. The legs are always next to the right angles. The hypotenuse is always across from the right angle. So now that we are very versatile with our lingo that we're going to use, let's start with our first one. This first one is called the leg-leg congruency. So what this is saying is like, hey, if I have two legs that are congruent to two other legs of a triangle, then the triangles have to be congruent. Now, realistically speaking, if you compare it to one that we already talked about, this is a side angle side, side angle side. But because this is a right triangle, we're just saying, hey, we only need two things, because we already know that angle is congruent as well. So we just need two more things. In this case, the two legs will prove the triangle is congruent. The next one here is the hypotenuse angle congruency. So again, we have our right angles, but those don't count in the thing. We need two more. We need hypotenuse and angle. So when it comes to this, the hypotenuse is one that has to happen. Hypotenuse is very unique. It's always across from right angle. There's only one of it. There's two legs, but there's only one hypotenuse. The angle, though, can be either one of those two. What has to be true, though, is that we have to use the corresponding acute angle. So if I'm going to use this top angle, then I have to use its corresponding partner over here. So that makes it hypotenuse angle, hypotenuse angle. I could also use the other angle and go hypotenuse angle this way, but I only need one of these two, but they have to match up. So if these two are corresponding to each other, and these two. Where we can get this wrong, where you might see a wrong version of this, is if they tell you, let's erase that one right there and put that back on there. They can say, hey, I got a hypotenuse angle with a hypotenuse angle. Not true, because they're not the same angle, so this will be wrong. So we got to look at it the old way, like that. All right. The next two, very similar to those, we have the leg angle congruence. So very much the same thing. We have it, our 90-degree angles, of course, and a leg. Let's say we're going to use this one. Now we use this one and then this angle right here. So we have to use this corresponding part, just like the last one. Both the angle and the leg have to be corresponding to each other. They have to be each other's version on a different group. We can't be mixing this angle with this angle and say, hey, these are congruent triangles. No. They have to match up. So that's very unique. Again, we can use any version of this leg and this angle with this leg and this angle, or this leg and this angle, this leg and this angle. It doesn't matter, as long as we're using the corresponding leg and angle. So we really need a leg and an angle. The last one is our hypotenuse leg. This is the most common of them all. We got the hypotenuse for sure, congruent to each other, and one of the two legs. Doesn't matter which one. Let's say we're doing this bottom one this time. So this leg to this leg, this hypotenuse to this hypotenuse, the triangles are congruent. All right, so quick review. Leg, the two legs are corresponding to their congruent partners. A hypotenuse and an angle. We got our leg and an angle, and then our hypotenuse and leg. So let's do a quick little proof here to kind of support this, what we just learned. So we got angle B is congruent to angle D. That is given information, so that's given. We also know, so let's actually go back and read the problem. So we got these fences that are parallel to each other, and we got a crossbar supporting it to form two triangles, okay? So we got to prove that these two triangles are congruent triangles to each other. So we start with the given information. We know A and D are right angles. They tell us that. And we also know AD is parallel to BC, so that's given right there. Now, there's a little gap right here. Let's look at this. So they're saying triangle ABC and CDA are right triangles. Now, we know these triangles are right triangles because they have right angles. So because of this information right here, we're able to say this, because by definition of right triangles, triangles, we have two triangles that are congruent, the right triangles. Now, we're not sure they're congruent yet. We're about to find out, though. Not all right triangles are congruent, but these will be. Now, we have to state this right triangle business, that they're right triangles, because now that unlocks our LL, HL, HA, or LA, our four congruencies that we talked about. All right, so going back to the parallel, the next part, we got parallel lines cut by transversal. Remember, when parallel lines cut by transversal happens, we're going to be talking about some version corresponding of these angles right here. Corresponding angles, alternate interior angles, alternate exterior angles, or consecutive interior angles, okay? We usually look at these three. Not very often do we talk about this angle when in this format, but we'll see. So we know our lines are parallel, so now they're telling us that DAC, this angle right here, is congruent to BCA, sorry, this angle right here. Okay, these two angles are congruent according to this right here. Well, they're congruent because, well, we have our parallel lines, we have our transversal, we have two interior angles are opposite the transversal. They're alternate interior angles. More specifically, alternate interior angles are congruent. All right. They also tell us that AC is congruent to AC. Yes, any side that touches itself on here is congruent by reflexive property. So now we look, I have an angle in the side, an angle in the side, but that side specifically is the hypotenuse, class. Yeah, so we have the hypotenuse in an angle that's congruent to a hypotenuse in the angle of another triangle. So the triangles are congruent by hypotenuse angle. And that's it. You guys have a good rest of your day. Bye.